a look at example 8.12. A bat strikes a .145 kilogram baseball. Just before the impact, the ball is traveling horizontally to the right at 50 meters per second, and it leaves the bat to the left at an angle of 30 degrees above the horizontal with a speed of 65 meters per second. If the ball and the bat are in contact for 1.75 milliseconds, find the horizontal and vertical components of the average force on the ball. Okay, so remembering, direction is important in this chapter. So these are all vectors, meaning there's like an I hat and a J hat. That's why it wants the components. So that means I'm gonna have to do a problem in the I hat direction. So I'm gonna have to look at the X component of the force, the X components of the velocity. Same thing in the Y direction. So we start out with it moving in at 50 meters per second. That means that my V naught X is going to be 50 meters per second. I'm going to choose to the right as positive and up as positive. And my V naught Y is going to be 0. When it's hit, it now comes off at 65 meters per second, an angle of 30 degrees above the horizontal, but this is to the left. So my Y component, I'll do X first, I guess, is negative 65 cosine of 30, and my V naught Y is going to be 65 sine of 30. And these are in meters per second. All right, so let's go ahead and start plugging in and solving for that force. So I just need to divide that delta T over. So my X component of my force is going to be the mass, my 0.145, times the final, which was my negative 65 cosine of 30 minus my initial, which was 50, all divided by my time, which was, what was it, 1.75 milliseconds? Yeah, so then we got to change that. So 0.00175 seconds. This gives me an X component of my force, and you see I got these negatives up here. So I do get a negative coming out of here. Negative 8,807 newtons. This negative means it's to the left. So then I can say this is 8,807 newtons left for an average X component force during that 1.75 milliseconds. The Y direction, okay, so we'll do the Y direction next. So Fy is going to be my 0.145 times my final, which was my 65 sine 30 minus the initial, which was 0, all divided by my 0.00175. Gives me a Y component of the force. We should get a positive number here, 2693 newtons. The fact that it's positive in my Y direction means it's up, so 2693 newtons up. There you go.